Welcome to Shared VPC Solutions. Welcome everyone. Today we're diving into one of the most important networking concepts across the three major cloud providers: shared VPC solutions. This is something I encounter regularly in multi-account environments, and understanding how AWS, Azure, and GCP handle this differently, yet similarly, is crucial for any cloud architect. We'll explore how each provider enables you to share network resources across different accounts or projects, the terminology they use, and most importantly, memory techniques to keep them all straight in your head. The core problem we're solving. Let me paint you a picture. You're working in an enterprise with multiple teams. Each needs its own AWS account, Azure subscription, or GCP project for security and billing isolation. But here's the challenge. They all need to connect to shared services like databases, monitoring systems, or on-premises networks through VPN gateways. Without shared networking, you'd have to duplicate VPN connections, NAT gateways, and other expensive network infrastructure in every single account. That's not just costly, it's a management nightmare. This is exactly why all three cloud providers developed their shared VPC solutions. AWS VPC Sharing Deep Dive. AWS calls their solution VPC Sharing, and it's beautifully simple. You designate one account as the VPC owner. This is your central networking account. Then you share specific subnets with participant accounts using AWS Resource Access Manager, or RAM. Notice I said subnets, not the entire VPC. That's a key distinction. What's brilliant is that participants can launch resources in shared subnets, but they cannot modify the networking infrastructure. Security groups and NACLS are managed centrally. I have used this extensively in organizations where the networking team maintains the VPC infrastructure while application teams get the subnets they need. Azure's different approach. No true shared VNet. Here's where Azure is fundamentally different, and this trips up a lot of people. Azure does not have true shared VNet functionality like AWS or GCP. You cannot deploy resources from subscription B into a VNet that belongs to subscription A. This is a hard architectural limitation in Azure. Instead, Azure uses VNet Peering with hub and spoke topology. You create separate VNets in each subscription, then peer them together. It's connection between VNets, not sharing of the same VNet. This means you're managing multiple VNets instead of sharing subnets from one VNet. It achieves similar connectivity goals but with a completely different architecture and cost model. Google Cloud Shared VPC. Google Cloud's approach is the most similar to AWS. They call it shared VPC, and it operates at the project level rather than the account level. You designate a host project that owns the VPC and shared subnets. Then you attach service projects that can use those shared subnets to deploy resources. What I love about GCP's implementation is the fine-grained IAM control. You can grant different projects access to specific subnets, and even specific operations within those subnets. The host project admin controls the network infrastructure while service project users deploy their applications. Key terminology comparison. This is where things get tricky. Each provider uses different terms for essentially the same concepts. Let me break this down with some memory techniques. AWS has VPC owner and participants. Think of it like a house owner letting guests use specific rooms. The owner controls the house. Guests use the rooms. Azure uses hub and spoke. Visualize a bicycle wheel. The hub is the center with shared services. Spokes are the individual VNets connecting to it. GCP has host project and service projects. Imagine a hotel host showing service providers to their designated work areas. The host owns the building. Service providers work in assigned spaces. Set up commands in process. Let me show you the actual commands you would use for each provider. I always recommend starting with AWS, since it's the most straightforward. For AWS, you use the Resource Access Manager service. The commands are intuitive. Create a resource share, add subnets, and invite accounts. Azure requires VNet Peering commands. You will typically set up hub-spoke using either the CLI or ARM templates. The peering is bidirectional by default. GCP uses the compute networks command with shared VPC enabled. Then you attach service projects to the host project. The syntax is clean and logical. Real-world implementation architecture. Here is how this typically looks in production. You will notice the pattern is remarkably similar across all three providers. The central network account or project contains shared infrastructure, like NAT gateways, VPN connections, and security appliances. This keeps costs down and management centralized. Application accounts connect to shared subnets or through peering, giving them access to shared services while maintaining isolation for their own resources. The beauty is that each application team can deploy independently while sharing expensive network components. Security and access control. Security models differ subtly but importantly across providers. Understanding these differences is crucial for proper implementation. AWS gives you granular control through IAM policies and resource shares. You can limit which subnet-specific accounts can access, and what actions they can perform. Azure relies on RBAC and network security groups. The hub-spoke model naturally creates security boundaries between different spokes. GCP's IAM integration is probably the most flexible, allowing you to grant specific permissions at the subnet level, even down to individual operations like creating instances. Cost implications and best practices. Let's talk money, because cost is often what drives the decision to implement shared VPC solutions. The biggest savings come from sharing expensive components like NAT gateways, VPN connections, and load balancers. Instead of paying for these in every account, you pay once in the shared VPC. Data transfer costs vary by provider. AWS charges for cross-AZ traffic even within shared subnets. Azure charges for VNet peering traffic. GCP is generally more lenient with intra-region traffic. Best practice. Always implement monitoring and cost allocation tags to track usage by different teams or applications. Memory techniques summary. Before we wrap up, let me share the memory techniques that have helped me keep them straight over the years. Remember, HOG, host, GCP, owner, AWS, hub, Azure. Each represents the central entity that controls shared networking. For participants, think PSS, participants, AWS, service projects, GCP, spokes, Azure. These are the entities that consume shared resources. The key insight is that all three providers solve the same fundamental problem: sharing expensive network infrastructure while maintaining security and billing isolation. Once you understand one deeply, the others become variations on the same theme.